So good day, everyone. I'm Liu Huawei from National University of Singapore, the U.S. editor board of the Journal of Building Design and Environment. It's truly a pleasure to welcome all of you to our emerging forum. The emerging forum focuses on new directions, methods, and ideas in the field of building and environment research. It aims to bring together scholars and encourage the participation of those engaged in innovation studies. The forum serves as an important platform for in-depth exchange and collaboration between the journal and the academic community, and fostering intellectual dialogue and advancing research innovation. And today, we are truly honored to welcome Prof. Duan Zhenhua and Prof. Liu Chao, award-leading research in green buildings and concrete. Professor Duan will be presenting on complex characteristics of melted source recycled aggregate and intelligent prediction of recycled concrete performance, and followed by the Professor Liu, who will present on 3D printed recycled concrete walls from interlayer shear performance to seismic performance. And before introducing our distinguished speaker, I'd like to take an opportunity to briefly introduce our Journal of Building Design and Environment. Journal of Building Design and Environment was founded in 2023 as an international gold open access journal, providing a high-quality platform for researchers worldwide to ensure academic excellence. The journal follows a rigorous single-blind peer review process and publishes 3 issues per year. As part of a commitment to supporting researchers, JBDE will waive all article processing charges for accept papers until 2029, allowing scholars to publish their work free of charge, with a target impact factor is 7. And the JBDE aims to establish itself as a high-impact academic platform in the fields of building design, environmental sustainability, and urban development. At the bottom of the page, you will find 3 QR codes. If you need to know about a lot of our journals, please feel free to contact us. JBDE is proud to be guided by the distinguished editorial leadership team, honorary editor-in-chief of the journal, Prof. Kang Jian from University College London, is a globally recognized expert in the building environment. His leadership played a key role in shaping the academic vision of the journal, and JBDE is jointly led by 2 editors-in-chief, Professor Zhang Limao from Huazhong University of Science and Technology, and Prof. Wang Xiangyu from East China Jiaotong University, who is also fellow of the European Union Academy of Science. Editorial team of the journal is committed to upholding the highest standards of academic quality and relevance, ensuring that the journal continues to reflect the latest advancements in building design and environmental research. And the JBDE editorial board brings together leading scholars from around the world, including Prof. Albert Chen, Prof. Jack Chang, Prof. Mike Santamaros, and Prof. Vivian Tim. Under their guidance, the journal is steadily establishing itself as the trusted platform for impactful academic exchange. Also, JBDE welcomes members to this U.S. editorial board from around the world. Our current U.S. editors are outstanding researchers in the fields of building design and building environments, with strong academic fundamentals and international perspective. In addition to the regular issues, JBDE actively organizes special issues on emerging topics, providing a platform for researchers to explore scientific areas in their great depths. These special issues is led by Prof. Liu Chao, myself, and other colleges. We warmly welcome scholars interested in the topic to submit their manuscripts. And for more information about our special issues, please visit our website. Okay, let's briefly introduce the speaker of today's presentation. The first presentation will give us is Professor Duan. Professor Duan is currently an associate professor and PhD supervisor at the College of Civil Engineering in Tongji University, and served as the duty director of the research section on recycled concrete structures and construction. He has been selected for the Shanghai Pujiang Talent Program and the world's top 2% scientist list. Okay, Professor Duan will give us the presentation title is Complex Characteristics of Multi-Source Recycled Porous Aggregate. Recycled aggregate and intelligent prediction of recycled concrete performance. Let's welcome Professor Duan. You will share the screen.
Okay.
You can see.
Okay, can you see my screen?
Yes.
Okay. So thanks for the introduction of Shear, and also my thanks for the invitation and organization of the journal. I'm Zhenhua Duan from Tongji University, and today I will give a presentation on the title. The title have revised a little on the quality assessment of multi-sources recycled aggregates and intelligent prediction on the properties of recycled aggregate concrete. Here, RA means recycled aggregates, while REC means recycled concrete prepared with recycled aggregates. I will present from the 5 aspects, and firstly, let's talk about the background. As we all know that during the past 20 to 30 years in China, the rapid development of construction industry has led to serious problems. For example, the natural resources like sand and gravel are in short supply, with the price are soaring. And at the same time, the generation of construction and demolition waste accounts for nearly continues to increase, and accounts for nearly about of the whole associated carbon emissions. Therefore, to achieve the green and low carbon transformation of the construction industry, how to recycling of the construction and demolition waste and make full use of its low carbon potential has become one of the bottlenecks. Recycling of construction and demolition waste into recycled aggregates or recycled power, and then to prepare recycled products by replacing natural materials has proven to be an effective way. So the scientific utilization of recycled aggregates has become a crucial direction. This is also an inevitable trend in future of concrete technology development. However, due to the complex sources of waste and significant difference in demolition and recycling stage, the quality of the processed recycled is complex and highly decreased. And we can notice that the source of construction and demolition waste come from the facilities, from the concrete structures or brick concrete structures, and the recycling the recycling process maybe from the mechanical demolition and some other form. So the recycled aggregates produced a generally very variability in the properties. Currently, there have been many breakthroughs in the research of recycled aggregate concrete, and its engineering applications has been already achieved. However, due to the complex quality characteristics of the recycled aggregates mentioned above, their use in concrete may bring about the following three major problems. The first, recycled aggregates generally have high water absorption and faster water absorption rate, making its quality very difficult to quantify. And second, the composition of concrete fluctuates largely due to the introduction of recycled aggregates, and the evaluation is difficult to clarify. Finally, and the most importantly, the performance of recycled concrete is highly discouraged and prone to fluctuations, making its properties difficult to predict by using the traditional method. So let's introduce some of the work we have carried out in quantifying the quality of the recycled aggregate. Firstly, we use these two images to demonstrate the complex quality characteristics of recycled aggregates. Compared to natural aggregates, the composition of recycled aggregates is more complex, since it may contain impurities such as bricks, tiles, glass, plastics, and so on. It's generally accepted that the biggest difference between recycled aggregates and recycled and natural aggregates is the presence of the old mortar. However, for each recycled aggregate particle, there may also be many ways of wrapping it with old mortar. We can understand the above phenomena as special temporal random distribution problem of old mortar in recycled aggregates. In order to explore this problem, modeled recycled coarse aggregates, namely RCA, is developed by artificially wrapping natural aggregates with varying quantities of mortar with different strengths. In this case, the main characteristics of recycled RCA, including quantity and quality of attached mortar, could be more precisely investigated with MRCA. This allows for the establishment of a qualitative relationship between the properties of MRCA and those of concrete. The power structure of MRCA was investigated using ICT. Significant differences in power characteristics were observed among aggregates with varying mortar contents and mortar strength grades. And we can notice that this means, for example, this means the aggregate, the natural aggregate contents is 20%, and the strength grade of the mortar is 30. And we all know that the test of the water absorption of coarse aggregates, especially the recycled fine aggregates, is very difficult. And so to overcome the limitations of the standard method, we have also proposed a time-dependent water absorption test method. Oven-dried aggregates were placed in a hydrostatic balance system and immersed in distilled water maintained at a constant temperature of 20 degree. A high-speed camera continuously recorded the mass variation of the system over time, enabling the establishment of type-dependent water absorption curves. This method allows more accurate and continuous measurement of the early-stage absorption behavior of aggregates, while eliminating the need for subjective judgment of their saturation state. And we can notice that about 20 test results can be about 100 test results can be recorded in just 10 seconds, with which the absorption degree of reservoir aggregates can be calculated based on the equation. And in the case of modern recycled concrete aggregate, absorption within the first 10 minutes accounted for about 54 to 64% of the total 24-hour absorption. The water absorption was also measured using the T-bag method, which shows that fine recycled aggregates reached saturation within just a few minutes. This finding highlights the distinct differences in water absorption behavior between the coarse and fine recycled aggregates. Then we need to understand the effect of the complex characteristics of recycled aggregates on the properties of RAC. In laboratory, when we conduct the test, we generally pre-treat recycled aggregate to a dry or saturated surface dry state, but they may lead to the neglect of the influence of the moisture content of recycled aggregates, as the water absorption rate of recycled aggregates varies greatly depending on the moisture content. For example, this all the air dry station, but this one and this one, for this one, their water absorption capacity is very different. This water absorption and release behavior directly affects the internal microenvironment of the concrete. As shown in the figure, moisture migrates between the aggregate and the mortar, forming a gradient in the water-to-cement ratio. And this in turn changes the actual effective water-to-cement ratio of the concrete. Therefore, there is a practical need to conduct a quantitative study on the effects of initial moisture content, as well as the corresponding additional water ratio on the effective water-to-cement ratio. Here, we introduced two key parameters. One is the initial moisture content, alpha, and the additional water ratio, beta. Studies have shown that initial moisture content of recycled aggregates significantly affects the compressive strength of concrete at different ages, and the optimal amount of additional water is not fixed. It needs to be carefully adjusted according to the aggregate's initial moisture content. And the effect is also reflected in the hydration process. And here, when we do the hydration test, we use the mortar with the fine recycled aggregates to instead of the traditional method by using the paste, because we want to examine in the mortar and the water absorption rate of the fire gate on the hydration. So based on the hydration heat test, we can obtain the accumulation heat release and the heat release rate curve of the mortar, which allow us to analyze its hydration characteristics. Completely dry recycled aggregate reduces the total 7-day heat release of recycled mortar by about 11.8%, whereas the saturated recycled aggregate increase the 7-day total heat release by about 14.3%. Therefore, for the recycled fire gauge with a low moisture, it can restrict the hydration, and where for the higher moisture recycled fire gauge, it may promote the hydration reaction of the mortar. And as shown in the heat release rate curves on the right, the end of the induction period occurs earlier as the initial moisture content of recycled fire gauge increase. Meanwhile, the duration of the acceleration period of the hydration reaction becomes shorter with higher moisture content. And through the hydration heat test on standard mortar, we established a quantitative relationship between the total heat released and the effective water-to-cement ratio. And through this method, we can determine the effective water-to-cement ratio. And we analyze the water-to-cement ratio and 4 different mortar conditions. And in the extreme case, where the recycled aggregate release all its internal water into the paste, the water-to-cement ratio corresponds to the upper limit of the effective water-to-cement ratio. Conversely, when the recycled aggregate absorbs water from the paste to full saturation, the water-to-cement ratio corresponds to the lower limit of the effective water-to-cement ratio. If there is no water exchange between the aggregate and the paste, the water-to-cement ratio equals the normal value calculated from the make design. Finally, the effective water-to-cement ratio can also be determined through some other analysis, and also the result shows that without additional water, the effective water-to-cement ratio increase as the aggregate moisture content increase. When the aggregate moisture content is below 0.65, the aggregate primarily absorbed water, with moisture moving from the paste to the aggregate, resulting in an effective water-to-cement ratio lower than the nominal value. When the moisture content exceeds 0.065, the aggregate primarily release water, with moisture moving from the aggregate to the paste. And after determining the initial moisture content of the recycled aggregates, we also further studied how the amount of additional water affects the performance of the recycled concrete. And the results show that when the initial moisture content is less than 0.5, the sum of the initial moisture and additional water should be around 0.7 to effectively promote hydration. And when the initial moisture content is 0.5 or higher, the sum needs to be increased to 0.8. And during the acceleration and deceleration stage, we observed a very clear pattern. And when the initial moisture content is fixed, the onset time and duration of the induction period of water hydration are roughly the same. And the amount of additional water also significantly affects the heat release during both the acceleration and deceleration stages. And the effective water-to-cement ratio also increases as the amount of additional water increases. Moreover, the higher the aggregate's initial moisture content, the smaller the increase in the effective water-to-cement ratio, and the slower the rate of the changes as additional water is added. Then let's move to the fourth part as the intelligent prediction of the recycled aggregate concrete. From the figure, we can notice that there are many factors that affect the performance of concrete. For example, the mixed proportions and the properties of each material, and also the process parameters and some other the parameters. The introduction of recycled aggregates will lead to the performance of concrete more difficult to predict. And some traditional methods can accurately predict the performance of concrete produced with recycled aggregates. So we have proposed the artificial neural networks, and we think that it might be able to solve this issue since it can both own the cognitive judgment of human and also the high-speed computing ability of the computer. This is a representative model, and it has the input layer and the function and the output layer. And for each node, the AN calculates output through a process called a forward propagation, and then continuously adjusts the internal connection width through error back propagation. After multiple training interactions, the network's output gradually approaches the target values. This self-learning and optimization process allows the AN to identify patterns from large amounts of complex data. For example, this is a simple model to reveal the working principle of the neural networks. And this is we have the two input value, and this is the initial weight and initial weight. We want to predict the target of 0.5. So this is the first forward propagation. After the propagation, we can predict the result of this one. We can notice that this one is that is a large difference between this one and the target value. But after the first back propagation of errors and the second forward propagation, we can notice that this one is more closer to the target value relative to this one. So after about 50 numbers of operations, it can close to the target. So this is a working principle. Then we have made a research program that we have collected the data from the published international literatures and to construct the model, and to train to verify. After that, we have also used the data of our own to model the different design strengths, different aggregate sizes, and different crushing techniques to verify the predictive ability of the constructed model. The prediction accuracy of the model is significantly better than that of conventional regression formulas. More importantly, by incorporating data related to the specific cases during training, the model's predictive ability is greatly enhanced, and this demonstrates that using ANA to get practical mass design for recycled concrete is indeed feasible. And most of the operation results also fall within the deviation range of the experimental measurement. And we also validate the model's generalization ability using data from other researchers, and the errors here in red can show that they are all within the acceptable limits. And after that, comprehensive dataset comprising about 659 concrete designs with a wide range of parameters were collected, providing high quality data for model training. Prior to modeling and in-depth correlation analysis of the decision variables was conducted to ensure the validity of input features based on this foundation. Two advanced optimized machine learning models were developed and applied. One is a genetic algorithm, enhanced backpropagation neural networks, and a particle swarm optimization based suppose vector machine. Both approaches integrate intelligent optimization algorithm to improve the performance of conventional models. And we also compare the four machine learning models, namely the BP, GBP, SVM, and PSO SVM, and the GBP shows the most favorable predictive outcomes. And improved Gray-Wolf optimizer, IGWO, is primarily developed to address the global optimization and engineering design problems by incorporating the hunting search strategy based on the dimension learning. This algorithm successfully enhanced the overall balance between the local and global search processes, while ensuring population diversity is maintained. And the single objective optimization reveals that the optimal REC mixes for compressive strings of 30, 40, and 50 megapascal achieve the reductions in carbon emissions and net carbon emissions of between about 61.8 to 68.1 compared to conventional mixes. These results highlight the significant carbon reduction potential that can be released by adjusting the composition of REC and specific strength design requirements. And we also do the multi-objective optimization algorithm. The result indicates that compared to the optimal mix proportions without considering carbon sequestration, the replements range for RCA and FA have widened the partial front of net carbon emission and cubic compressive strength. RCA with a higher water absorption appears in the partial front considering carbon sequestration because the carbon reduction benefit of low quality offset. Offset is adverse effects on strength. So, to summary, in this work, we have reviewed the quality quantification mechanism of multi-source recycled aggregates, and we also clarified the performance evaluation of the recycled concrete. And we have also proposed an intelligent prediction method for recycled aggregate concrete. That's all. Thank you for your attention, and comments and suggestions are welcome. Thanks.
Thank you so much, Professor Duan. Thank you for your insightful presentation on the complex characteristics of multi-source recycled aggregate and the innovation use of intelligent method to predict the recycled concrete performance. I think Professor Duan's presentation is very valuable guidance for sustainable construction practice. And we will have a discussion session after both presentations are finished. So please feel free to prepare your questions. Okay, I share the screen and let's welcome the second presentation. Okay, second speaker, Professor Liu Chao, who is also my PhD supervisor. Professor Liu is a doctoral supervisor and the duty director of Human Resources Department at Xi'an University of Architecture and Technology. He also served as a director of Shanxi Future Industrial Innovation Research Institute of Intelligent Construction, and he was selected for the high-level Talent Science and Technology Leadership Program by the Organization Department of the Shanxi Province Community. Is a recipient of the Shanxi Distinguished Young Scientist Fund and has been awarded the Shanxi Province Science and Technology Rising Star title. So Professor Liu will give us a presentation. Topic is 3D printed recycled concrete walls from Interlayer shear performance to seismic performance. Okay, let's welcome Professor Liu to give us a presentation. Professor Liu, you can share the screen. Yeah. Can.
Okay. My PowerPoint is okay?
Yes, it can see.
Okay, ladies and gentlemen, good afternoon. Thank you, Journal of the Building Design and Environment. I'm Liu Chao, come from Xi'an University of Architecture and Technology. It's very great honor to stand here and to share our team research with all of you today. My top report title is 3D printed recycled concrete walls from interlayer shear performance to seismic performance. The first is the research background. Compared to the cased concrete construction, the high storage, the difficulty to break through the high construction cost. So the construction industry should move towards intelligence, unmanned, and information technology. The China needs to seize the 3D printed concrete opportunities to lead the global intelligent construction wave. Emerging science and technology treat the American side this world, the 3D printed construction technologies are inevitable trend for the future of the industry. This is the three pictures. The right is the cased concrete construction, and the middle is the printed fabricate concrete, and the 3D printed is the right. Compared to the conventional technology, 3D printed concrete technology has the weightage of the efficiency, the cost effectiveness, environmental sustainability, and the great strengths with the complex. So at present, 3D printing has realized the multi-theme and the multi-field and the large value applications. The part two is the compression shear and shear the properties of the 3D printed reinforced recycled concrete. We call it short for 3DPRC combined units. For first, we can see the 3D PRC interlayer interface test method. So interlayer shear performance is different. Within the first 60 minutes, increasing the interlayer moisture, increasing the interlayer strength. So we found some characterization of the pore structure. The pore structure at the interlayer interface is different. We found with increasing interval time, the interlayer mocha strong deteriorated significantly. So next, we should to take another test with the 3D distribution of the pores. We can see some of the different pictures. The value of the pores larger than 10 in the interlayer increased significantly in the increasing print interval. So we can see the different, the part, and the different pore, the strength is. Next, we found some the modeling, the rubber 3D PRC board sleeve. So we can find some the 3D printed concrete and the rubber. So the bond sleeve modeling is different from the normal. We found some of the modeling, the calculations to solve the problem of the discount factor, alpha K S, and the important factor, the K1, K2, and other factors. So compression shear properties of the 3D PRRC, we should take some of the strength test. This is the compense. The first, we should, if the test is over, we found the following process and the following modes is different. The different parts, the different process and the modes. When the price is zero, the component showed the shear fractures damage. The next, the following process and the following modes. The cracks in the mattress structure was a step type diagonal crack along the traceway And the 3D printed members was affected by the different interference. So if we use the core column, so we should find some the different and the fallen modeling influence the mechanism of the 3D PRC with core column concrete. So next, we found some the different influence mechanism of the price ratio. Under the pure shear, the members had poor shear capacity, and the ones and the price was present, their load carrying has a significant increase. So next, we should to solve the problem of the impact mechanism of the interlayer reinforcement distribute on shear load capacity. We can find a method, but I think it is not the best. I think it is similar to the text number. So combined unit shear strength conclusion method. I think it is a better method, but it's not the best. So next, we should share the part 3. If we finish the part 2, we should use the 3D printed concrete walls. So how about the 3D printed concrete walls? These are so many buildings. For example, a building in Xi'an and in Yichang, Wuhan Yichang, and in Jiangsu province, Lianyungang. We should some the building, the RC column, the beam, and we should use some 3D printed walls. How about the walls applications program? We finish some the test of the structure. For example, the combination of walls, cross section, and the dimensions. This is the design of the component. This is the component is about 1.2, about 1.6 the meter. About this, what the walls is the a half of the two in the two programs is a half of the two programs. So this is some the reinforcements, the different the part of the reinforcements is from different of the common concrete. So if we have some test the different the train agreement, the concrete and the rebar the string, we have the loading device and the loading scheme, a mixture of the load and the displacement control was used for the test. We have the load and the displacements, the two part we should use for the test. It is the important is the combined wall printing process. For example, the picture A, we can shoot the cast part, the 3D printed part, the hollow part. We can see the blue is the cast part. The worker performance is very good, but the black and the white is the hollow part, and another is the 3D printed part. You can see the line of the printing the line. So this is the we filling some the filling process and the reinforcement and the core filling process. And next, we found some the interface characterizations. For example, the rebar 3D PRC interface, the concentrated on both sides of the bar and the significant increase in defect value. The different porosity of the different part, the three pictures, the light, the right, and the middle. So we can see the right is the 3D PC, the recycled concrete. This is the porosities, the interface, and the normal concrete 3D printed concrete, the line is null. So the important is the picture B. We can see this is the different interface and the different the lines. So the porosities, for example, the 3D PCFCC, the concrete, and the rebar, the casting air is different. So as above, we should take the 3D distributions. We can find some of the calculations of the shear strength. So the wall is the test is over. We can find some of the combinations wall fallen modes. This is an important part of the seismic construction test. So the wall static loop and the scaffold. This is the stiffness. So the different the 3D printed concrete and the different recycled ritual. The test is very important. For example, the stiffness. Okay, finish the single part. We share some research of the cluster construction and the high value applications of the 3D printed concrete. For example, the above one is the single part. Single part is the above some research work. We finish the single-ended stand or long construction. So the similar to the Olympic Games, we should to work hard to more efficiency in challenging the complex diverse. So I think if we have so many in the single part, yet for example, the multi-part cluster, how to building? The building is more efficiency. We have some of the problems. So I think we can get some the information from the news and the moves and the some in nature. For example, the right picture, we can see the cluster military applications. The Chinese name is 天使线路. Maybe the English name is the Angolos. We can see the cluster military application is very hot. We can get some the same information from the news, the Russia, the American, and so on. So cluster behavior and its applications have become one of the hot research topics today. There has been a new trend to conduct research on cluster construction by drawing on the behavior of the biological groups. So we can see the cluster behavior in nature, and the right is the robotic cluster construction technology. How to implement construction trust based on the robotic construction is a current international research. So we found example, the nature's cluster builders, the termites. The termites is very, very small, but there's home and so many so many termites building. Their home is a very big building. From the right picture, we can see this building is tall, Tom being a big boy, the strong boy. So we call Terman is a nature's cluster builder. How is about to finish this work? The building is a placement is a definite opportunity for intelligent construction of cluster. So we can do some research work to solve these problems on the machine or the plane, the mandate, our mandate, and so on. So we have the Shear operation, the partner with the Northwestern University and the Chinese name is the Zhongshan University. We get the laboratories and the research parts from biological behavior and the clustering system and the key technology, and we can find some cluster builders. So we do some research work and finish it, and we think we can get our visions. So this is our normal research work. You can see the right is the rabbits, the pink rabbit and the yellow rabbit. Inspired by the things, the mechanism of the leading organism and density drives self-organization, materials collection methods of the for cluster robots was process. The right is the multi-target, the different multi-target, the different planes, the different part, collecting experiment of the different robots, the pink and the yellow robots. So the ant-like multi-robot self-operate handling method was proposed to realize automated operative handling of the building materials by and the simple robot. We can solve the multi-robot cooperation handling experiment. This is the test and the research, some work. So next we should finish some of the human clustered robot, aiming at the needs of the future cluster construction process, in which opportunities and the cluster robots are in the common and in construction. A human cluster intertrack method based on VR. The VR is popular in China, in Chinese family life, and we should use the air tracking technology. It's purposed to realize the efficiency perception and the by the operator. So the air tracking technology, we should use this technology can solve some of the problems. Okay, solve the problem of the short opening time. It is the concrete, and we can use the intensity and the wide distance spacing. Okay, the last one is the conclusion and the outlook. So this report, we finished some, share some of the work, research work of the compression shear and the compression shear, the properties and some cluster construction. I think 3D printed it's high value applications in future. So thank you, the friends, and give some of the report. Thank you.
Thank you. Thank you so much, Professor Liu. I truly appreciate the valuable insights and the fresh ideas you brought to us, especially in 3D print concrete seismic performance. And W, can you out the screen share? I share the screen and to next session. Okay. I share the screen. 哎，刘老师，可以麻烦切换一下共享吗？我来共享。
哦，不好意思。OK。
Okay. Okay. Okay, once again, thank you to Professor Liu and Professor Duan give us a wonderful presentation. And now we move on to the open discussion session. We encourage everyone to actively ask questions and share your ideas. And anyone else who give some questions to Prof. Liu or Prof. Duan? You can also you can speak Chinese. Speak Chinese is also okay to ask questions. 哦，可以这样。我们直播间啊，有一位我们的这个出版人靳主编呢，从直播间引来了一个问题。他一个问题是针对多元再生骨料来源如废弃混凝土啊、砖块、砂浆啊的差异性的成分与微观结构的异质性当前的主流量化评价指标存在哪些局限性？那很显然，这个问题呢，应该是问给段老师的。好，段老师。
那个
您看到这个直播间有
刚才忘了
一个问题吗？
好的，我看到了，刚才忘了打开那个视频了啊。这个我简要的一个回答吧，就是我个人认为啊，就是因为现在呢，我们理论上研究的，比如我们理论研究，是因为它主要的因素，刚才我在那个介绍里面有提到，一个呢是它组成上，因为它我们大部分比如研究是针对的混凝土再生骨料进行研究，但它其实里面还包含很多杂质，包括砖、包括瓦、包括塑料、包括木块，还有一些微粉含量等。那如果是单纯的研究这个东西，可能我们会聚焦它的这个老砂浆，但是老砂浆它的时空分布是有很大的差异性，有很大的一个不确定性啊。那么我们现在主流的一些测试方法呢，包括现在压水值，包括我们的吸水率，包括我们的这个颗粒的一些匹配啊等等，都是针对我们这种天然料的天然砂质骨料的，而且它是一个很经验的方法啊。相对来说是没办法从理论上来去更好的去量化它啊。当然从实际的评估上来讲，就每一个指标呢，像比如我们吸水率、我们表观密度，都能够或多或少的来反映这个再生骨料是老砂浆的影响，但都是没有办法去综合的没办法把它给就是准确的来去表征它。就比如说我提到了一个，都知道吸水率很重要，但其实呢，再生骨料它有一个吸水速率的问题啊，那这一点你没有考虑好，那可能就会对它带来对它的一个准确的配合比的准确配置带来一个问题啊。那个华为，这是我针对第一个问题提了一个。
还有第二个问题。
有个第二。
对，还有一个来自直播间的提问，因为有两个直播间在腾讯跟另外直播间同步进行。问题是考虑到实际工程中多元再生骨料的动态混合比例，现有智能预测模型能否实现实时输入骨料配比与瞬时输出混凝土性能的动态预测？这个
问题就是当汇报的主题就很相关了，当然其实它不光是针对再生骨料的，我的理解呢是针对我们现在整个的混凝土，因为以往呢我们对混凝土来说，我可能是鲍鲁米公式是非常经典的，我只要知道它的水灰比，我就基本上能够把它的强度范围能够确定下来。我是在30到40兆帕，还是40到50兆帕，还是多少？但是现在呢，而且呢，我在这个水灰比的基础之上，我可能比如还有几个水泥用量啊，这几个核心的指标，我只要抓住就行了。但是现在呢，我们讲究的都是一些精益化就尽可能的降本增效。那这个时候，就是以往的这一些被忽略掉的，包括我们以往可能比如把土料，我们都看作是一个惰性材料， 但其实我们骨料它的粒径、粒型、它的级配等等都会有影响。那现在这种情况下呢，我们就需要把可能对我混凝土性能哪怕0.1%，它只要有贡献，这个因素我们都要明确，都要能够把它怎么样去检测到。那这个为你提到的这个输入配合比来输出混凝土性能，其实这个路径早就实现了，这路径是完全没问题可以实现的，只是问题就在于你的精准度可不可靠啊，是不是可靠？那么从可靠的角度来说，就是我们现在就提到了我们现在所有的我们现在都在讲这个人工这个智能啊，人工智能赋能，大家都在过于强调这个它的就是这个算法啊，强调它的智能算法。但是对我来讲呢，我个人一直认为是，除了算法之外，我们还要有一个可靠的大数据库。就现在我们现在就是很多时候呢是没有这么一个数据库，就是包括我们像小班站的它很多比如说它会牵扯到。那么这个一个可靠的数据库呢，我认为有两个因素，一个因素呢是到底哪些性能指标对于你需要预测的性能，有影响，你要首先要把这些因素都给明确下来就是比如说举个例子，就是我们在讲含水状态、含水程度，骨料的含水程度在搅拌站几乎很难把它给检测出来因为大家都知道这个很重要，但是确实是没有办法就是那么我们就要明确哪些因素对它有影响，这是我们第一个要做的。第二个呢，是我们怎么样能够把它给测取出来，而且测的这些结果呢，既然是大数据库就要采用一个统一的方法，比如说采用一个尽可能的避免人工带来的误差比如一组数据，你测的和我测的，哪怕是采用同一种方法，它的结果也有很大的差别。那这个时候，我们就是怎么样能够把这个能够给控制住。有了这两个之后呢，我们所建立这个数据库，我感觉是再加上我们的这个目前的这个智能算法，是很容易能够实现配合比的这个就是精准设计的那个华为我简要回答这样回答。
好的，段老师，感谢段老师的回答，也感谢直播间来自直播间的两位这个同行专家们的这个问题。
感谢
好，
提问
我们看还有什么问题吗？等等，看有没有问。
主任你好，
3D 打印混凝土，刘超老师
主任你好，
这边的。好，你好，你好。
我有个问题想请教一下刘教授。刘教授您好，谢谢您刚才的精彩分享。我有一个问题，我的问题是在3D 打印墙体的抗剪或者抗震中，这个层间钢筋会起到什么样的作用呢？就目前关于3D 打印混凝土墙体，它有没有成熟的设计规范？您能不能给我们讲解一下？就是在还有就是在确定最佳配均率的时候，我们应该遵循什么样的设计思路？谢谢。
好的，谢谢啊。刚才这位同学问的一个问题，确实也是目前困扰3D 打印混凝土结构的一个挺重要的一个问题。目前呢，现在我们还没有国家级的标准在进行应用。那么目前我们打的一些建筑的我们这小型的建筑或者基本上是按照以300平米以内，然后统一验收这种形式来进行的。所以这样的话呢，就是结构的这个部分呢，确实是存在的这样的一个我们需要考虑的一个地方。那么这里面其中有一个很关键的，就是刚才就是提到的关于配筋的一个问题。那么配筋在混凝土结构、钢筋混凝土结构当中，抗震性能研究这块应该这个工艺，目前的我们这个3D 打印混凝土，也就是传统的这种灯材建造工艺呢，基本上都是层层堆叠、逐层建造。那这样的话呢，对于它的竖向钢筋的布置是比较棘手的一个问题。那相当于就是竖向钢筋，如果出现的话呢，我们这个钢筋混凝土能协同打印的话，那这样的话，这个混凝土打印头就会和钢筋在工艺上有一个碰撞，这样的话呢，就不好布置这个竖向钢筋。那所以呢，现在目前采取的方式，一般情况下采取一个水平的铺筋方式。但是我们通过刚才分享的这个实验来看， 目前水平向的这个钢筋的分布，它的主要的一个问题就是影响了它这个层间接面。那么在堆叠的过程里，它的这个层间接面本来就是一个薄弱区域。当把钢筋放进去之后，当然我们在抗侧向力的时候，它发挥了一定作用，但同时粘接性能，那这样的话呢，又造成了一些缺失，所以这个是目前的一个比较麻烦的事情。而这次分享的这个成果当中呢，我们是采取了自己的一个方式啊，采取了我们自己的一个方式，那就是我们采取了一个新铸组合墙体这样的一个用结构的方式来解决它。新铸这块呢，我们主要以 3D 打印来快速打印它这个模壳，然后呢，我们把这个钢筋笼放进去，浇筑这种高性能的再生混凝土啊，这样的话呢，就是工作性能很高啊，工作性能很高的这样的一个再生混凝土，形成一个新筑，就是刚度比较集中的地方。同时呢，就是这种连续的组合墙发挥这 3D 打印的这个作用，然后形成这样的一个连续抗刚度变化不大的、抗侧向刚度不大的这样的一个新筑组合 3D 打印组合墙体。那么通过这种结构形式的设置来解决目前工艺上的不足，这个就是目前的一个现状情况和我们解决的方案啊。好，谢谢。
谢谢，这非常专业的问题。这个好，你先说，你先说。
主任，我再没有其他的问题了，没有了。
好，谢谢啊，这个非常专业的问题，也是非常专业的回复。这个3D 打印混凝土结构配筋领域呢，现在目前还有很多未知的问题待于解决，希望大家也能一起来探讨一下这个问题。好，两位老师呢，其实都是智能建造跟再生混凝土领域很知名的专家，大家的研究方向也有这个各自的特点，也有我们相交集的地方。比如说再生混凝土跟3D 打印混凝土，二位老师其实都是有从事的啊。我也想去针对跟二位老师一起来讨论一下啊。3D 打印混凝土，在这个怎么说，在低碳 3D 打印混凝土领域里边，这个未来的这种研究应该向什么样的方向去开展呢？因为现在我感觉就在这种时代下啊，这发展太快了。以前上学的时候啊，觉得这个一些创新点啊，可能是1年一变，我现在感觉可能是半年甚至几个月就一瞬而过就变了。也想跟两位老师一起来交流探讨一下这个大家的这个对这个领域发展的现状的一个想法。好，这是我的问题了。
刘老师先那个吧，你是这方面的专家。
哎呀，你是专家，
你是3D 打印混凝土吧？主要是3D 打印。
那我抛砖引玉啊，我先来讲，我先说一下自己的理解。目前的情况就是我首先第一个，绿色建材提出来的其实是解决以前咱们这个发展过程当中的一些，就是说我们是不是还要先发展后治理啊这样的一个传统发展问题。那么改革开放这几十年来讲，我们其实发现这条路不可行，所以现在肯定要走的是，当我们有这个绿色建材在应用的时候，肯定是和现在时代要求的，比如像我们土木领域这种智能建造协同并进的这样的一个思路。所以我认为智能建造和绿色建材应该是一个协同发展的一个过程，这个应该是一个永恒的主题，我相信它应该会持续很长一段时间，这是我第一个观点。第二个观点呢，就是关于再生的这个材料，再生混凝土这个材料如何和3D 打印结合？其实，当然段老师可能更有发言权啊。我其实想说一下，就是他们的结合其实并不是说我们拿一个绿色建材强行的和智能建造方式搞一个1+1。这个再生混凝土里，它其实很多的，包括它以前的吸水性、工作性能，我们不满意的地方，其实它放在3D 打印里，有可能对于我们这种挤出快速建造。速干的这个性能的要求，相反它还是个优点，所以我觉得这种应用呢，其实并不是一个强行的1+1的一个方式，所以我觉得目前结合呢，应该说也是一个很顺的一个过程啊，这个是一个很顺理成章的一个过程。我想说一下它的这个发展啊，我们其实现在觉得，因为目前整个土建领域，这个整个的市场需求在发生一个巨大的调整。其实我觉得对于3D 打印和再生固废结合的时候，第一个对于多元固废端的这种包容性啊、容纳性更多的固废放进来，我觉得这是一个挑战啊。第二个方面呢，就是我们在3D 打印应用这种方式的时候，能不能在挤出的过程里，刚才我们想挤出的这个包括孔隙啊，包括它层间接面这些，将这种不足啊，能够变化成我们在做一些功能材料设计的时候的一些 优势啊，就将不足转化成一种优势。所以这是我3点的三个方面的观点啊。好，谢谢主持人。
谢谢刘老师的这个深刻洞察跟远见的这个一个回复。
那
是你
那主持人呢，我也在刘老师的基础之上谈谈我的看法。刚才刘老师讲的几个点我都非常赞同。然后因为这一块儿3D因为是刚才也算是个命题作文吧，低碳3D 打印混凝土，对吧？然后它的一个发展从一定角度上来说，因为我以前也做了一些3D 打印相关的一些工作，但我一直是在思考一个事情呢，就是3D 打印混凝土，就3D 打印，就是我们现在是把它作为一个学科去研究，还是把它作为一个施工的工法？因为它最早提出来，可能就是相当于是我们现有的这个预拌、预制这2种方式，在它一个上面的一个有效的补充。啊，从这个角度上来说，就会比较简单一些。那就是哪一些场景啊，这2种方式，我们对比3种方式，哎，我的3D 打印更有可能更环保，还是说我更容易从技术上更容易实现，我来去做这个事情。那如果是从一个学科角度来说，那就比较大了，它就是既包含材料、设备，包括它的一些这个设计，还有它后边的一系列结构等等一系列的，那就会导致的一个点就是就像我们现在讲的，我们整个土木工程学科，它可能都已经在开始往下滑，整个区域的建设的量也没那么大，怎么去支撑这个往后走啊？就是一个也不成熟的一些思考吧啊，我是感觉可能这2个要去思考的。然后如果是和就是前面讲的低碳，那就是说就以我们的建筑工费为例啊，当然也可以和其他的工费去结合。包括我呢也是一直都是认为，再生混凝土不能等同于低碳混凝土。很多时候呢，可能用了再生反而是高碳了，因为在这过程里边，在整个处置流程上，它的产生的一些高碳排啊，以及呢，在采用了不合理的一些应用方式啊这一块儿等等，所以呢，就是那如果是和这个，如果至少是目前是和建筑工费如果结合起来的话，我个人认为可能就是像一些这种改扩建的啊、尤其是呢像一些就是能够怎么样把这种建筑工费能够就地规模化、资源化利用的啊一些方式，同时呢，在这过程里面我又能够给3D 打印混凝土能够就是我们建筑工费再生骨料又能够给它提供不管是原料支撑也好，还是从它的这个材料自身的这个流变性能、可打印性的调控上也好，提供一些支持，这样的话可能才能够实现1+1大于2啊。我就这2点啊，主持人，
谢谢段老师，谢谢段老师。谢谢段老师进一步从多角度这个补充了一下您的这个见解，确实有不一样的认识。这不仅是一个研究啊，也可能涉及到一个学科领域的一些问题。好的，我们来看还有没有现场有专家学者们啊、同学、老师啊的一些问题呢？那如果没有的话，那我们今天的这个新兴论坛呢就结束。然后也非常感谢2位老师们、2位教授们的这个精彩报告。2位教授都非常忙的，百忙之中抽出时间，我们非常感谢。同时呢，也要感谢来参与本次论坛的各位专家学者们。好，那我们本次论坛到此结束。好，刘老师、段老师还有沙编辑，好，那我们这个下周见。